Hello again. In this tutorial, we're going to have a look at loops. Specifically, we're going to be looking at the for loop. So let's just go ahead and get started and create a new Java project. We'll call this one Project 5. Finish that out and add in a new class. Call it driver, like we've done before. Type in our skeleton, public static void main string args. An opening and closing curly brace. Okay, so as I stated before, we're going to be looking at the for loop, and it's first of all good to know when to use a for loop, because we have a couple of other choices. So a for loop is good when you know where you're going to start and where you're going to end up. For example, if we wanted to count between 1 and 10 or something like that, we know the starting value is going to be 1 and the ending value is going to be 10. So a for loop is a really good candidate for that situation. So what you're going to see in a lot of textbooks and websites is something that looks like this. So let me just stub it in here real quick. I++, and then we'll talk about each part of this. Okay, so this is a standard for loop. It executes about 10 times, or actually it executes exactly 10 times. But let's dissect it, okay? To begin with, you can see that we use the keyword for. That means that we're going to loop something a couple of different times. Notice that we have a pair of parentheses here, an opening and closing pair, and then we also have an opening curly bracket here, followed by a closing curly bracket down here on line 7. Okay, so if you look on the inside of this pair of parentheses, there are 3 different things separated by 2 semicolons. There's a semicolon and here's a semicolon. So what are those 3 things? Well, the first thing is an initialization phase. Notice that we're declaring a variable here called I, which is just going to be our counter, and we're going to initialize its value to 0. Now realize that this initialization section here occurs exactly once. We only do it one time at the very beginning of the loop. If we move on to the second part, you can see that there is a test to continue. So what this is saying is, so long as I, or the value of I, is less than 10, then we're going to do everything between this opening and closing curly brace. So we're going to execute what's on the inside of those braces. Okay? Once we've done that execution, we're going to come up here and we're going to increment the value of I by 1 in this case. That's that I++. That's our shortcut operator that we saw in the previous tutorial. So let's put a system.out.println statement on the inside of this. In fact, let's do something like this, and we'll just print it all on the same line to make it a little bit easier to read in the console window down below. All right, if I were to run this, you could see that we get the values 0 through 9. Now this may be a little bit of a surprise for you, especially since you see the number 10 right here. So let's figure out what's going on. Well, we initialize our value I here to 0, and then we print that out to the screen, and that's where we get this 0 right here, followed by a space. Once we've done this, remember we come up here to this third part, and we execute whatever statement is there. In this case, it's an I++, so the value of I is 1. And then we come back here to a test to continue. 1 is less than 10, so we go inside the loop, and then we execute line 6 again, which is where we get our 1 and a space. Okay, so this is going to occur any number of times. And the interesting part is where it terminates. So let's say that we make it to the point where I is equal to 9. So we system.out.println I, which is 9, which is this guy right here, followed by a space. Okay. We come up here to increment this variable one more time, and this is the reason actually that the loop fails. It actually stops. Okay? Because we said I++, I is now equal to 10. We come back over here to our test to continue, and this is where you can see that it actually fails. 10 is not less than 10. 10 is equal to 10. So this whole expression right here is false. So at this point, what happens is we kick down here to line 8, and we continue processing. Now there's nothing at line 8, but you get the main idea. Okay, so this is again what you would see in a standard textbook or something that you would have on the web. Now it gets a little bit more interesting when we start changing things like the data types. Instead of incrementing by 1 each time, can we do something a little bit more creative? Well, sure you can. Okay, so instead of saying something like I++, how about I plus equals some other value such as 0.5? Okay. So now you can see that we have a floating point counter that's going to go from 0 and it's going to go up to 10, but it's going to do it in half steps, or it's going to do it in something other than 1. So if I were to run this now and save the changes, you can see down here in our console we get some different behavior. We get 0.0, 0.5, 1.0, all the way up here to 9.5. Okay? Also realize that we can do a couple of different structures to this. I don't have to declare this float on the inside of the for loop. In fact, if I were to try to come down here and say system.out.println I again, it should give me some problems. It's going to say, I don't recognize what I is. And the reason is because I has been declared on the inside of this for loop, not on the outside. So technically line 8 can't see it. So how would we solve this problem? Well, it's relatively straightforward. Instead of declaring this float on the inside of the for, what I can do is declare it on the outside. So I could start it out as 0 right here and get this. I can now eliminate that initialization section. So you're really not going to see stuff like that in books because it's a little bit of strange code, but then it begs the question, well, what else can we do? In fact, what's this final I going to print out as? If I were to run it again, you can see that it does run, but it actually makes it to 10. Now that may come as a surprise too, but think about it. Because we incremented here, we actually made it to 10, which caused this part to fail. It drops down here to line 9, and then it actually prints out the value of I. So you can see that we did make it to 10, which caused this part right here to become false. Okay? So then that begs the question, well, what else can I move out of the for loop? How about this? I could just as well take this thing and I could put it here inside this loop and remove it altogether and just have my test to continue right here up at the top. Let's put our semicolon, can't forget that. Okay, so if I were to run this, it may be surprising, but I get the exact same behavior. But then you're saying, hey, well, maybe we could move this thing out. Yes, you can, but we're going to skip that for now. Okay, so hopefully that gives you a little bit more understanding about the flexibility of for loops. Again, it's really good to use these things when you know where you're going to start and where you're going to end up. So in the next tutorial, we'll start to look at some of the other loops and some of the things that you can do with them as well.